Okay. I'm not offline. I'm very much live. Okay, cool. Yeah, I don't have anybody actually look at this. But then the question becomes, how on earth do I share that I am live? Is there like a stream link or something? Whatever. Anyway, if anybody ends up joining, that's awesome. I'm recording this. So the idea is, see, I knew nobody would be on it. I'm just gonna end up writing this stuff out loud. So I'm doing a machine learning thing for work. We wanted a Jupyter notebook. Awesome. Yeah, I know. Perfect. Yeah. The Titanic competition on Kaggle. If you've never used Kaggle, it's a really great place to start machine learning. My goal is for today to just practice machine learning. I want to do it once a week, probably on Fridays, and I'm going to just stream it because why the heck not? Like, honestly, why the heck not? So we're gonna save this as Titanic 1 for now. So the point of this is trying to figure out who survives on the Titanic, and we're given some data. To start out with that, I don't know if I have the Kaggle API installed. I think I do. Let's see if I do this. If I do have the Kaggle API installed. What the heck do you mean unauthorized? I just want it. It shouldn't give me this problem. Well, we'll just download it and we will put it on our nice little thing. Okay. So we have gender submission. Oh, that was mine. We don't want that. Oops. So we want the train data. We want the test data. We want the train data. So, for anyone who hasn't ever done any machine learning, the idea is to take a set of data and use that data to gain inferences from. So we're going to have a computer program written in the Python gain insights or inferences from the data here. So first things first, we always want to just import our data. Now, so this is Markdown. So step 1, import data. If you've never used a Jupyter notebook, you can do this in just any Python script. I like Jupyter notebooks because the kernels allow you to do nice retries. And coming from a physics background, it's really handy. We do a lot in notebooks, like a lot of mathematics stuff in notebooks. So, how on earth? I always forget my Python. This is what happens when you don't do Python every day, and this is one of the reasons why I have a Chrome tab open to the side. 1, for Googling, 2, to show that it's okay to Google. Oh, I need to do it in pandas. I knew that. So let's do import pandas as PD. No, as PD. No, guys. I still want to edit this. PD dot data frame. Pandas data frame import CSV. See? And they have the Googles for all of our helps. Data frame to CSV, see? I knew there was a thing. Pandas to CSV. And we provide the path. The path is data /train.csv. So with the and we want to import this as a data frame. We're going to call this Titanic DF for data frame. So let's just print out the Titanic data frame and see what it looks like. I always like to just look at the data and see what's in there. Head is really good for that. It just prints out the beginning rows. What did I do wrong? That means that that's empty. Oh, it's not connected to the server. What's this business about a server? Pick how to connect to Jupyter default. Yeah, let's just use the default. Can you connect to Jupyter though? I want to run my notebook. Can you start it? Restarting kernel, fetching specs. I mean, I can just do this in any Jupyter kernel. Let's do Python 6. Perfect, now it should work. So let's just rerun everything since it hasn't showed up as running yet. Save that. Come on. Just run it, guys. Why didn't it? So that ran. Why didn't the other ones run? I'm about to scrap this and just pull up a Jupyter notebook next to it. Should we just do that? What do you mean Jupyter's not a command? Jupyter so is a command. Do I not have Jupyter installed? How do I not have Jupyter? Oh, did I misspell it? I did. There we go. There we go. Now we should have a nice Jupyter notebook that we can actually run. This is not code. This should be marked down. There we go. And this thinks it's marked. Oh, everything was wrong. That's why it wasn't running. Problem number 1. It thought everything was wrong. What do you mean I don't have NumPy? Who knows? Let's add this and just do a pip 3 install NumPy. I honestly don't know if I well, let's do a pip install upgrade then. I know it's already satisfied. Pandas. What version of pandas is this? Oh, that's an export. I think this is supposed to be from CSV. How come nobody told me that? Do we need to pip install pandas? Oh, it says we have it. From CSV. What to do, guys? What version of pandas am I on? 1.5. Oh, is it read CSV? Probably is. Read CSV. Let's do read CSV. Okay, and now this is... okay, there we go. There we go. So it looks like we have a nice little table here. We have a passenger ID, survived, passenger class, name, sex, age, SIB, SP, parts, ticket, fare, cabin, and embark. Well, since we don't quite know what that's due, Titanic, diff, come on. And then we'll do a describe. I think it's actually like the full thing. I thought there was supposed to be an autocomplete somewhere on here. Oh well. There we go. So it says we have a number of entries. We have 891. Looks like not all of them have an age listed. That's good to know. And we aren't going to need anything that's not numeric, right? Because we have, like, the name's not going to help us. Like, it's not like people were discriminating based on name. Maybe race, but that's too much work. Sex, yes. Age, probably. So we probably don't need cabin. Embarked, SC. Does C mean... let's go back to here and see if they tell us what embarked meant. 10 of 12. Yeah, I know. What does embarked mean? Does it tell us? Embarked. Oh, it tells where it left from? Yeah, then that definitely doesn't matter. Good to know. So let's go ahead. Let's start by just cleaning the data. There should be a keyboard shortcut for switching to Markdown. It's like Command-Shift-B. Oh, it's just M. So I should just do M. No, right here. Oh, so it is marked down now. So now we're going to clean the data. I like to label these because when somebody comes back and does it later, they know what's going on. So we've already decided what we don't need. So we're going to take Titanic underscore clean equals Titanic df, and then I'm pretty sure exclude is a term exclude columns. Well, let's exclude columns. Yeah, so selecting, excluding sets of columns in pandas. Great. Oh, we drop them. Cool. So it's called drop. So we will drop. So then we are going to actually drop, and it's Titanic underscore data frame. And we're going to just drop Titanic. And then, so columns lets us choose it by name. Oh, no, we don't need that. We'll just do name. So the ones we decided we didn't need were the ones that were words. So we don't need name. We did want sex, so we'll leave that in there and we'll just change that to a number later. We don't need ticket, we don't need cabin, and we don't need embark. What do you mean it just, what did it do? I did something wrong. Should we just try doing the axis equals 1 and see if that fixes it? Invalid syntax. Oh, I didn't put the number 1. Oh, look, I forgot the brackets, guys. All one of you. What do you mean embark not found? Embark's right there. Oh, embarked ed. There we go. Hey Lulu. Lulu's my dog. She's coming to see me. And then let's go ahead and we'll do that here. Clean. And there should be, so let's see if we can replace column. I don't want to search there. Data frame. Replace column with number. Change column to numeric. Change type of columns in pandas. That's not the kind of... Convert string column. How to convert string column to int? What did they say to do? Yeah, I don't like that. Oh, pandas replace string with number. Python's pandas replacing strings and data frames with numbers. Oh, like that. Yeah, look. So we replace. So what about data frame replace? Let's look at this. Replace string. Yeah, okay, great. What is it? So can we replace more? Okay, so that's what I do. So I do. Okay, I'm gonna this example right here, where it says data frame replace with the two arrays. Replace. And we can probably just do this on a single column, but since the names, I mean, I'm not going to be super careful since that name only happens in one column. So I can do male, female, and do 0, 1. Right? That should work. What is df? Ha! Df's not a thing. So we want to actually Titanic clean, right? Because I don't want to do a second one. I just want to do that. So now if I did, let's go ahead and, oh my goodness, I didn't want to run that. Oops. Titanic. Let's just do, let's do the head again. Cool. So yeah, now the sex we have. So if we were to describe that, it should tell us how many women and men there are. Well, it says that more than half of them are women. It's not a count. I would have to do a count on it. So we're good. Oh, yes. Yes, this is a giant thing of Dr. Pepper. It's brain fuel. I think both of my dogs are in here with me, being very quiet. I went to the park earlier. So awesome. So now we're gonna go ahead and we're still cleaning the data, but I'm gonna actually relabel this as, this is marked down now. We're gonna call this prepare for training. Because we need to get the data, we need to have an X and a Y. So, does train test split have 4 or 2? So we're going to do a train test split. Train test split is really important when you're doing machine learning, because essentially, I'm just looking it up so I can copy and paste the code. Yes. Perfect. Like I said, we're trying to gain inference, but the inference doesn't really mean anything unless we have something to compare it against to. So the training data is the data we use to gain inference for our code, and the test data is what we use to validate our inferences. And so we take a set of labeled data and we have that labeled data give us a set that we want to train on and a set that we want to gain inferences from. So first what we need to do is we need to take the label from our data. So our label is what we're trying to learn, and our data is what's supposed to tell us those things. I should have closed my window, that was really loud. And I know my mic did not cut that out. I know, Lulu. Hey! Lulu! Lulu! I know, there are dogs outside, huh? So what we're going to do is we're going to have a Titanic. We're going to call it Titanic X. And this is going to be our data that we learn from. Right, and so that's going to be Titanic clean. Oh, I don't want that capitalized. Titanic clean. Oh, I'm so used to them. Titanic clean, and we're going to drop, now that we remembered how to drop, we're going to drop the column survived. Because that's what we're trying to learn. Like, we're trying to determine if somebody survives. I must need to put the axis on there again. Axis equals 1. Alright? Okay. And then the data, so what we learn is what we're going to call Y. So Titanic Y is going to actually be Titanic clean, and then we're just going to take survived. So that's what we're going to evaluate it to be. So let's go ahead. No, who can spell survived? I can't spell survived. It's really great to spell survived. I can't spell survived. Okay, so let's go ahead and we will split it just like it says to do right there. So we'll do X train, X test, Y train, Y test. Okay, so X train is going to be the data that we learned from. And the X test is going to be the data we use to test our model. And then Y train is what we're teaching with, or what we're trying to learn. And then the test is what we're going to use to to validate our model. You'll kind of see that a little bit later. So we take our Titanic X. I don't know what that says. There we go, Titanic X. Let's go ahead and we will put this all the way down. Actually, let's just do this. That should work. Titanic X so that you can see it. Titanic Y. I'm just following the form from the screen on my right. Hopefully that's also your right. It's not inverted. Titanic X is capitalized Y. We're going to do a test size. So what I'm doing is I'm doing a 75-25 split. So that means I want 75% of my data to be used in training and 25% of my data to be using in testing. And we're going to add a random state. So a random state shuffles it for you. This is very important to shuffle your data. Reason number one. I just picked 32 out of the ethers. Reason number one is sometimes you get a data set, it will have it'll be ordered. So for example, we could have all of the men at the top, all of the women at the bottom. Well, if we're trying to train on that, men and women could have a huge effect on if you survive. And if we're only training on men and only testing on women, we're losing things. It could also be ordered by age. So if the youngest are at the top and the oldest are at the bottom, we could be only training on babies. And hopefully, they put children first. And stuff like that. So randomizing really helps to kind of just it's just a really stupid way to make sure. Oh gosh, I know I must have done that wrong. I know you can actually do this though. It's a really stupid way to make sure that you're just being fair in your evaluations. So let's go ahead. So let's just make sure that this looks kind of how we want to. So we'll do a test X and we'll just do a describe on it. Right? Disgrace. Perfect. So now the test has 223. It's about 50-50 standard deviation on. It's a little bit skewed towards the female side of it, but that's fine. It is different. I mean, it's almost the same as before, which means the randomized works. We've got a good variation on age. We have obviously a baby. The oldest person's 74. What was that? What is sibs? Like, that might not be number of siblings, spouses aboard the Titanic. Oh, that could be important. I hope that people with 5 spouses weren't traveling on the Titanic. But that could be very important. We have the socioeconomic. Mistresses and fiancés were ignored. Okay, that makes sense. Parch, dataset defines. Number of parents' children aboard. That could be important too. Like, I guess the idea is if you had a high number of siblings, like if you had 5 siblings and you had parents, then you would be considered a child, most likely in the lower class. Which I guess could be relevant. Like, I don't know if removing that or adding it would make it more accurate. That's something we'd have to tell later. But, you know, it's fine. So let's start. I think I want to do 2. I want to do a linear regression, just because, why not? And then I want to also do an SVM, which is a support vector machine. Just as 2 classifier types and to see what happened. So, I like the ones from Sci-Kit Learn. How do we insert below? There we go. So I like the ones from Sci-Kit Learn. They've been really good to me in the past, so I'm gonna add them to this. sklearn, linear regression. Example. This is still really big. Cool. We don't need the data set, but we do probably want that. So, as you can tell, I am a huge fan of copy and paste. I do not think that people should code without copy and paste. Oh. Yeah, did I not? I don't have the F, do I? Okay, so we already have our data, so we're gonna start here. And just add some stuff. So we're gonna create linear regression model. Regressor. So these we need to change, right? So we have an X train, we don't need to call it diabetes, and we have a Y train, just like that. Perfect. So let's go ahead, and we're gonna go ahead and we're gonna call this just the predictions. And we only need to do the test set. So basically, the predictions that we're gonna have come out, we're going to compare those against our Y test. And if they're the same, our model is 100% accurate. And if not, we're going to evaluate how accurate it is. That's why we imported this mean squared error and R2 error. Just to kind of help us. Look, they already did this for us. Look at me. So I'm just going to copy this again. And so this is Y test. And just pred. Pred. Y test. We should be able to run this now. Right? Is it... Okay, I broke something. Woohoo! Regular for X train, Y train. Train model using training sets. Yeah. What didn't it like? Sample weight. CSR array. Contains non-infinity values. Oh! That's right. Where? I thought we cleaned all of that. Uh-oh. Oh no. What do we do if the age is nan? What do we do if the age is nan? Nan just means null or empty. What do we do if the age is unknown? Why would the age be unknown? Let's see if this gives us any insights into age. If age is estimated, its form is that. But why do we have ages that are empty? Who did that? Look, they just don't have them. Well... Ooh. Well, if the age is unknown, I guess I'm going to do a replace on age. That appears to be the only thing that is nan. Let's do, so pandas, replace nan with well, we can do 0 for now, and then I just want in column. Data fish stack overflow. Okay. Oh, I can just do fill NA. I believe dataframe.fill NA with 0 replace true. And I can just do it on one column. Sweet biscuits. Okay, so I'm actually gonna just come do this up here. The reason being is I can apply it to everything because it's a notebook. Equals Titanic. Oh. I almost have to sneeze. Clean and fill and A. So in place equals true to actually change contents of whoop-de-doo. Oh, they're saying I don't have to do an equals if in place equals true. Okay, cool. So we do in place equals true. I'm gonna just do something completely weird. Like, we know nobody's age is gonna be like 3,000. So that the idea is I'm telling the model that this is just an anomaly value. Hopefully. I don't know if that'll actually work. If somebody watches this and knows that what I'm doing is completely stupid, please tell me. Okay, that seems to work. So actually what I'm gonna do is I'm gonna stop the kernel and rerun everything. I don't need to rerun everything, but I just want this to be in like all of them. So I just want to run everything. Because why did you? Okay, yeah. So this reran all of the things. Hopefully that error's gone. Just to incorporate that change. Linear regression, error, blah, blah, blah. What does pred not... Oh, look at that! Cool. Okay. So I believe what coefficients is doing is it's giving me my values. I have no idea what actually regcof does, so that was dumb of me. It's not on here? Yeah. Like, what does that actually do? Yeah, like, it should give me an array with my X and Y values. Oh. Why didn't I print the score? So, I want to do this. Oh, score returns a coefficient of determination r squared of the prediction. So what's the difference between doing R2 score and score? Well, I can tell you we can figure that out. right? We just do this. Come on, guys. And this would be regressor dot score x and y. Why are they doing x and y? Yeah, that's... Obviously, I'm unaware of this, so I'm just going to take this out and go back. Okay, cool. Okay. Okay. So I guess if I were to do this, print score, and then I would do regressor dot score, and then I would do x train, right, capital X, and then I did y train. We would want these to match. The mean squared error is really low. I think that's something that should be really good to just look up right now so that you can read it. And so I don't actually lie to you. And I like Wikipedia for these things. Ooh, that's too big. So error deviation is the average measure. Okay, yeah. Do they have a picture? Why don't they have... Oh, do they have a picture over here? Do you have a picture, Wikipedia? They don't. Okay. So where's my linear regression? Do they have a picture? Well, I mean, this is a root mean squared error. Yes, I know. I just want a nice picture. I apologize. I'm a visual person. And yeah, let's see. I know we did it in sklearn, as shown there. I just want to show you. Okay, well, here's an image of a linear regression, which is what we did. So the idea is we have a series of data points, and we're trying to just draw a line in between those data points. As so. So that line will determine basically if you live or die. So if you're above the line, you live. If you're below the line, you die. And the mean squared error tells you about how far away from the line on average your data points are. So the fact that ours are 0.16 is really not bad. That means that on average, like, our data points kind of sit really close to the line as being, I mean, sorry, it's not whether they are close or far from the line. It's the difference between the distance of our expected answer and the predicted answer in relation to the line, right? So the more off we are, the bigger the mean squared error. On our example for this, we are able to plot it. So I'm actually going to do this for us because this can be really helpful to understanding how accurate our model is. But we have to, I believe, include this package. And it'll also help call me on my BS if I'm telling you any BS. So let's remove all of our things. We didn't call it Y prediction, we just called it that. Okay. And it should show us, what? They must be the same size. They were. What do you mean they're not the same size? They should be the same size. Test and test should be the same size. X test. Test test. Train. Which one's not the same size? X test and Y test. See, this is when it's helpful to have a nice little, I can just add a cell. Where's my lines? Oh, I literally moved that one up. We don't want you, I don't want you at the very bottom. Okay, look, see, look. Where did our things go? You should be at the very bottom too. Oh, Lulu. Lulu. There we go. Lulu! No. 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 So shape actually will tell us how big they are. What's the split cell? Insert cell is just D. Oh, for below. I knew that. Watch this. What? Tuple object is not callable. Do I have to do size? What? Data frame shape? Am I forgetting all of my things? Oh, it's because it's a NumPy array. I knew that. Yes, train test split returns a NumPy array, not... Okay, there we go. So that's our answer, right? This is just the Y, and that's that. Oh, why does test have a 7 on it? What line did they say was wrong? Yeah, this one. Diabetes X test, diabetes X train. They didn't use the train test split like I did. Oh! I know why. I know why. I know why. I know why. So we're gonna just do age. And this will help us see how age related to the final results. Because I'm not dumb. Oh, I did something wrong. Oh gosh. Oh gosh. Let's do this. No, stop. So we have age here, and we do age here. Remember, this is linear, so there should really only be one. Why didn't I like that? I guess that means they didn't use age that much. Let's try sex. Obviously, it prefers the whole thing. I'm pretty sure it selects them out of there somewhere. Okay. This is another call for help. Size isn't a thing. Sex was the thing. Oh, it's backwards. Like, there should be more data points than there are lines, and it should be... I just want to see... Let's get rid of... Let's do this, right? So this is saying... Yeah. Should be male or female. It shouldn't be... Sex shouldn't matter that much. I guess, yeah, age makes more sense. Okay, I'm not explaining myself very well. So, my point is... Oh! See, my thousands are messing up our nans. I'm gonna do 0 then, since they didn't have anybody at exactly 0. Okay, so... So, what's happening is, remember how I did this? Well, that 3,000 is what's being represented over here, right? So, we have 3,000 and a million, and then 3,000 and 0, basically being survived and dead. So we can't see this right here. I guess, yeah, so if we have alive and dead, and you have 3,000 alive and 3,000 dead. So obviously, it's trying to plot a line in between there. This shouldn't be that. This should be our coefficient values. That's really weird. It's really weird that they did that, right? Like, we should be using these coefficients to determine. Now that makes sense why we have so many of them, right? Because we have so many different x values. Okay, so let's try restarting it. I'm not explaining this very well at all, and that's on me, but I also don't know how to explain it. Jake, when did you buy Jake's my nephew. When did you buy a basketball? Oh, that's your indoor one. Yeah. You gonna go to that park?
Maybe tomorrow.
Okay. I'm talking to Twitch. I'm coding on Twitch. They can't see you. You have to come over here and wave. Okay, now they can see you. That's my camera.
I thought you were talking to someone.
Nope, I'm talking to the one viewer that is myself.
Oh. That's what's up.
Yep, that's what's up.
Thanks, what's the matter? It's just a ball.
See? Now this makes more sense. Look at that. You have, these are the ages. This is also a little bit weird, right? Because we have dead is 0, alive is 1, and you have kind of a line that should go in between them. But yeah, and it would like go like this, kind of. Look at our numbers though. They're like almost the same, so obviously it only affected the points and nothing else. I think logistic model is just changing this to logistic. I was only gonna do an hour. Nope. Okay, so we're gonna keep the linear model. I'm gonna go ahead, I'm gonna save this, and we're gonna go to the VS Code. And I'm going to go ahead and be done for today. Yeah, actually, let me just go ahead and went real quick. At the very top, I'm gonna add a cell. And this is going to be a bash cell. I know it's a magic cell, blah blah blah. And this is just to get that information that I didn't do. Hopefully, it can help somebody. So then I'm going to do a make dir data in case they actually do it, and then we're going to copy what we're going to move. Anything with a CSV to data. No such file or directory. Yeah, I know. Well, nobody actually needs to do this. That's bash coming out again. Okay, cool. I mean, them. Cool. Now I'm just going to save it. This will be all available on the GitHub within 10 minutes. Thanks for watching. If you have any questions, feel free to reach out to me on any of the things. And I will be here next week.